All right, continuing on with our 8.2 lesson, we're looking now at square root properties. If an equation is of the form ax squared equals c, so we're missing the x term, the one that has the b coefficient, we can get the x squared piece all alone by dividing by a on both sides. So then it would be x squared equals some number. Then we can just take the square root of both sides to get x alone. Then we would have solved for x. Now remember, we're going to get a positive and a negative answer when you take the square root. So for example, the square root of 16. You might think right away, oh, it's 4, because 4 times 4 is 16. But it's also negative 4, because negative 4 times negative 4 makes positive 16. So there's a positive and a negative answer for these. And you can show that by just writing plus or minus 4. So let's look at some of these examples. R squared minus 6 equals 10. Well, we want to get the r squared alone, so we add 6 to both sides, and we'd have r squared equals 16. How do we get r alone? Again, we take the square root of both sides here. This means that on our left side, we just have r, so r equals square root of 16, we just went over that, is positive or negative 4. So r could be either of these, positive 4, or it could be negative 4. Either one. If we square it, it'll become 16 minus 6 equals 10. 8x squared equals 488. Well, we need the x squared piece alone, so we'll divide both sides by 8, and we get x squared equals 61. To get x alone, we take the square root on both sides. This will leave us with x equals on this side, and the square root of 61, there isn't an exact number that makes that square root of 61. We also can't break it down any. We can't divide anything out of it, so we can leave this answer as plus or minus the positive or negative square root of 61. If we can't find an actual answer, it's okay to leave things in this radical form. In our last unit, we learned about the radicals and how to simplify them. If you can simplify them, you should. If not, just leave it as positive or negative square root of 61. For this one, negative 5 minus 7n squared equals negative 698. We still need to get it in the form where the n squared term is all alone. So first off, we need to add 5 to both sides. When we do that, we get negative 7n squared equals negative 693. We added this 5 onto both sides to get rid of it there. This minus 7n means that it's a negative 7 times n squared then. So from this point, we need to divide the negative 7 from both sides to get that n squared alone. So n squared equals 99. To get n alone, we take the square root of both sides, and we would get that n equals positive or negative square root of 99. Now going back to our last unit though, we know how to simplify this. Square root of 99 is the square root of 9 times the square root of 11. 9 times 11 is 99. We know the square root of 9 is 3. The square root of 11 we don't know, and it doesn't break up anymore, so that one is done. That has to stay. So to simplify positive or negative square root of 99, we would call it positive or negative 3 square roots of 11. So this would be our answer, our final form. On the flip side of that, to undo a square root, we would square both sides of the equation after you isolate the radical, so getting just the square root piece all on its own. So for solving equations with radicals, we isolate the radical or the square root by using opposite operations. We undo the roots by raising both sides of the equation to that power, and we watch out for extraneous solutions. This means if our answer comes out to a negative, if we were to plug that back into the original equation, we can't have a square root of a negative. So any negative answers, check and make sure that those would actually work in the original equation. So for example, we've got the square root of x plus 1 equals 4. We need to get this square root piece all alone. So we'll minus 1 from both sides. to get that the square root of x equals 3. Now, how do we get rid of a square root? We square it. So we'll square both sides here. This side will just become x, so we squared it. This side will now become 9. So x equals 9. To double check, again, kind of checking for extraneous solutions, we'll plug 9 back into the original. Square root of 9 is 3. 3 plus 1 is 4, so this one all checks out. All right, we've got negative 6 times square root of 12r equals negative 36. So first off, we want the radical all alone, so we'll divide both sides by negative 6, and we would get the square root of 12r equals positive 6. Now we have the radical piece all alone, so to undo that, we square both sides. This will get rid of that square root symbol on that side, so it's just 12r. 6 squared is, of course, 36, so we have 12r equals 36. To get r alone, we divide by 12 on both sides, and we get r equals 3. Again, double check for any extraneous solutions. If r was 3, 12 times r, 12 times 3 would be 36, which is positive. So we do have the square root of 36. That works. Square root of 36 is 6. 6 times negative 6 is negative 36. So this checks out okay. Now we've got square roots on both sides. Square root of negative 3 minus 2v equals square root of 2v plus 9. To get rid of the square root, we square both sides. So then it'll become negative 3 minus 2v equals 2v plus 9. We want to get all the variables on one side, all the constants on the other. So we're going to add 2v to both sides. And we're going to minus 9 on both sides. When we do that, we'll get negative 12 equals 4v. Now, to get v alone, we divide both sides by 4, and we'd get negative 3 equals v. Now, here's a place we'd want to double check, especially if it's negative, for any extraneous solutions. If we do negative 3 as our v value, multiplied by 2, that gives us negative 6. So negative 3 minus negative 6 is like plus 6, becomes a positive 3. So this is the square root of positive 3, which does work out. As long as this is a positive underneath the square root, it's okay. 2 times v means 2 times negative 3 is negative 6. Negative 6 plus 9 is 3, so this side becomes the square root of 3 as well. So neither side gave us the square root of a negative, so this is okay. It checks out. And we know that square root of 3 does actually equal the square root of 3, so this one is okay. And we have square root of n minus 10 equals 4. Well, to get rid of that square root, we'll square both sides and get n minus 10 equals 16. To get n alone, we add 10 to both sides, and we get n equals 26. So again, just double check that. If we plug in 26, back to our equation over here, 26 minus 10 is 16, which is positive, so it works under square root. Square root of 16 is 4, or it's negative 4, but we are just looking for 4 here, so this one does check out in the end. 26 works out okay. Here we've got negative 5 equals negative 6 plus the square root of a over 2. So, like before, we want to get the square root piece alone, so we'll add 6 to both sides, which leaves us with 1 equals square root of a over 2. Get rid of that square root by squaring both sides. 1 squared is 1. So we have 1 equals a over 2. Multiply both sides by 2 to get a alone, and we would get 2 equals a. Double check for extraneous solutions. If 2 was a, we'd have 2 over 2. 2 over 2 is 1, which is positive, so it works under the square root. Square root of 1 happens to be 1. Negative 6 plus 1 is negative 5. So this does all work out just fine. And that'll actually be our last slide then. So that's it for our video lesson.